This is problem 101 of Neetcode 150, house rubber. So we're going to be given an integer array nums. And basically at each position, we have what they call a house, and each house has a certain amount of money. And if you access if you access one of the indexes inside this nums array, you're going to have the amount of money that particular houses contains. So we are being told that you can't rub two houses that are adjacent. Otherwise, the problem would have been too simple. Just sum up all the integer inside the nums, rub them all, and your problem is done. But if you actually rub two adjacent houses, there's apparently a security alert that will just blow up, so you're going to be arrested. So um, let's see how we can actually solve this problem. So what we will be willing to do is we're going to use um, some dynamic programming, and I'm going to try to keep track of what is the maximum amount of money I can do at every single position. So let's say we start here, so we're nowhere. We can decide to start robbing this bank for $100, but if we rob this bank for $100, we can't rob this $500 banks, right? But if you rob this 100 banks, we can go rob this 300 banks. So I will have to keep track of basically how much I am making by robbing this bank, and what is the maximum amount of money I can make overall. So to do so, I will basically keep track of a first rob and a second rob, which will represent two scenarios, or one in which I didn't steal the first bank and the second one in which I stole the bank. So initially, I will have a scenario where I didn't steal the bank and then another one where I stole it. So initially, let's say I stole $100. Well, I'm gonna, let's say, rob $100 here. So this is the rob 2. But the rob 1 is a scenario where I didn't steal that money, right? So if we keep going, we're gonna have a first rob that will be, we will set equal our first rob to be that 100, and we will set the next rob to be equal to that 500. So we know that now we have 500 here. So that now when we go to this 300, we will just basically set a variable that will be equal to the maximum between what we can do with our first rub plus this n rubs, and what is the current maximum. So we know that if we add our $100 plus our 300, we will have 400, but the maximum is actually 500. So we want to make sure to keep track of this 500 here. So that's pretty much the concept. So we're always going to have like a first rub, and we're going to have a second rub. And we know that the second rub here, if it is done, so if you did that robbery, you can go steal the next bank. So the next bank is always going to be set to the next bank plus the first rub. So we're going to have 300 plus 400. And we want to make sure that the value that we store here, so we keep track of the greatest value we could have done so far, is going to be set to the maximum between that first rub plus this next rub and the current second rub. So in this case, it's going to be 500 compared to 400. So 500 is going to win, and we will advance our 500 one step further. So we're going to have our 500 here. And then we're just going to basically set our R1 to be the position of our R2, and we'll just put our R2 here. So now we're going to do the same concepts here. So we're just going to compare again what is the maximum amount of money between stealing the rub 1 here and the next rub here. So here we can see we will have 500 plus 150, so we will have 650. So here we will set it equal to 650, because this is greater than the 500 maximum we could have done at the R2. And then we're just going to move again. We're going to set our R1 to be equal to our R2. And same principle again, we will see if by adding 400 to this previous R1 here, so 500 plus 400 is going to be 900. So we're going to have this, and that 900 is going to be greater than the rub2, which is R2. So 900 is greater than 690. And finally, we are going to move again, or R1 and our R2. And notice that the R2 is going to point to the greatest value, well, the biggest amount of money we could technically steal without basically triggering the alarm system. So this is the concept we're going to use. So I need my R1 and my R2, and both will initially be equal to 0. Now I will go for every single bank. So for R in nums, I will set basically the temporary value. So TMP, this is going to be equal to the maximum between n, which is the next bank to steal, and the R1 and R2. And then I will just move my pointers again. So my R1 is going to be equal to my R2. And my R2 is going to be equal to the temporary value here. And then I will just return at the end my R2. All right, so I hope this makes sense. That's exactly what we did previously. So what we have here is that we're going to have a rub1, we're going to have a rub2, we're going to have n, we're going to have n plus 1, and on. So we know that if we do our R1, if we steal there, we can go steal n. But if we go steal R2, we can go steal n. So basically that temporary is the maximum value between that steal and, well, the R1 plus the n, so the next steal, and also the R2. So this is the temporary value. Then we just move our R1 by 1 to the right. We move our R2 by 1 to the right as well. And we ensure that this R2 value is going to be equal to that maximum value. And at the end, we can simply return this maximum value, and it will give us the maximum amount of money we can steal in these banks. All right, so I hope you learned from this video, and I hope to see you in the next one. So before we leave each other, I just want to speak about the time and space complexity. Notice that in terms of space complexity, we never created any other storage. So we're going to have a space complexity of big O of 1. And in terms of space complexity, we are going linearly once through all the houses inside our list. So we're going to have basically a time complexity of big O of n. And this is the most efficient way to solve this problem. So I hope you learned, and I hope to see you in the next one.